Good evening, students. I welcome you for another lecture on ethers. What we told you, students, the reaction of the ethers last time, the most important reaction of the ethers, which was discussed in the previous lectures. You know what happened? We told you the ethers, students, ethers have got what type of linkage? ROR dash. Okay? When
Yes,
you
sir.
heat them with excess of HI, then what is going to happen, student? One, there are two products which are formed, student. One is Ri and other is R dash OH. And we have told you already what type of products are there, students, whether what type of alkyl halides will be there and which will be alcohols. We have told you. Do you remember what we said? If the R group student is 1 degree, then the lower R forms Ri. ठीक है? If it is 1 degree.
Yes, sir.
And if R is 3 degree, then we have told you the reaction mechanism shifts. This is SN2 mechanism. This proceeds through SN1 mechanism, students. If R3 is 3, then what you get? The product you get is tertiary alkyl halide and the other alcohol. This was an important point. And this is a very important question I said for the question.
Yes.
And also, earlier also, we told you students, if we have some compound like this, what is the name of this compound, students? We told you. What is this called? If you are heating with HI, then what are the products, students? What are the products? Which is the OH group, where OH group attaches, and which is the alkyl halide, student, in this case? You know, it is difficult to break this bond as compared to this bond.
Yes, sir.
Why? Because this has partial double bond character, sp2 hybridization. So we always said that you are getting phenol, and this is a very important reaction, student, asked in paper many times. So we are aware of this, and here we have given you example that if this is the ether, this is the ether, this R group, you can see that this is a 3 degree alkyl group, student, and this is a 1 degree. If I say R dash and R, then it is clear then 3 degree alkyl halide is formed. This is a 3 degree alkyl iodide. Clear?
Yes, sir.
And the next is the alcohol. So for example, student, we are getting and starting with a question. Give the major products that are formed by heating each of the following in HI. So you have to tell fast, student, you are heating this with HI, what will be the major products in these cases? He is talking major products, because there could be more than one products. So what major products are expected from question one, student, and from one, what will be the major product in this first case? You have 30 seconds, students, or 1 minute to complete the reactions. See that I always say practice is very important, student. Unless we will solve questions for the coming examinations, it will become difficult to appear in the paper. So we must be able to solve questions, students. All right. What is the product in this case? You are having this compound, student, CH3, CH2, CH, CH3, CH2O, CH2, CH3, student. You are heating with HI. What product you will get? What product you will get, students? Tell me. Now, there are two R groups. These R groups and these R groups, are they 1 degree, 2 degree, or 3 degree? What type of R groups are there, students? Tell me. What type of alkyl groups are these, students? This is 1 degree. This, what is this? 1 degree, 2 degree, or 3 degree? Fast.
Sir, this is 3 degree.
Huh?
3.
How it is 3 degree?
Sir,
This,
sir, which one, sir?
this one. Where is the 3 degree?
Oh, sir, this is 1 degree.
This is also 1 degree.
1 degree.
Then what alkyl halide will
But
be
the
formed? Which alkyl halide will be formed? I told you what we have written. Which is lower, this one or this one? SN2 reaction is taking place. Which is lower? This one is lower as compared to this. There are more groups attached to this, as you can see. The attack has to take place at this carbon. This is more crowded. This is least crowded as compared to this. Naturally, you will get CH3, CH2I. Plus, what is the rest one? Then rest, if this bond is breaking, then the next is the alcohol. What alcohol you are getting? CH3, CH2, CH, CH3, CH2OH. Got it? These are the major products. In this case, we have to write in the exam.
yes, sir.
Okay. See the questions, what type of questions are given in the paper. These are the important questions, students. They will be asked anytime in the paper. Now, second case, what will be the products if I react with HI? Reaction is with heated with HI, students. What products you will be getting, students? So you are heating with HI. What products I'm heating? What is the product, students? There should be no doubt now. How much time? 1 minute is given for one question, students. Your time has already started. We should have sufficient amount of practice to answer the question. It's very important, students.
Yes, sir.
Is there 3 degree?
Yes, sir. Yes, 3 degree, sir. Yes, sir.
And this is 1 degree. Then what I said about 3 degree and 1 degree? Here we have already written. If 3 degree, then what is the alkyl halide? This is the product which we have to write. Then the next one is the alcohol. Then, because you know this proceeds through SN1 mechanism, this proceeds through SN2 mechanism. We have already discussed the mechanisms you have in your notes. Yes or no?
Yes, sir.
Okay. All right. This is that was all to be written for the paper. 1 mark question, 1 mark question. They will see this. Okay, 1 mark. So students, you have to be able to attempt question and give answers in the exam. That's the most important point. If you cannot give question and answer, then what will we learn, student? Our lectures are interactive. They are meant so that you can understand the basic concepts. At the same time, you should be having ability to solve questions which are important for the exam, students. So we have to try as many questions as possible. They can be asked to you. Now we are saying this compound, students, CH2O. Tell me what products are going to be formed, students. You are heating with HI, heat with HI. You have to write the product, students. What product will be formed? How do I said that the story is that which bond is the cleavage of, these are all examples of cleavage of carbon oxygen bonds, but there are 2 carbon oxygen bonds, this one or this one, which will be cleaved. That is our point. This bond or this?
Sir, the right one.
Right one. If this is cleaved, then how it can be cleaved?
Sir, left.
This is
CH2
carbon
CH2.
and this is benzene ring. So cleavage must be taking place at this point. So what happens, student? Then, if this is a taking place, then I should get attached to this. So what you are going to get then, students? CH2I, and you will always get phenol. Important. This is an important reaction, students. Such questions will be asked in the paper, and this is how we do the. It is an expected question for the coming paper. Very important questions were discussed today, and the reason they are important have been discussed. I again and again repeatedly say, student, try to answer questions, and that will be the only way to learn and to do better in exam. Any doubts here, student? You can ask me if you
No,
have
sir.
any. Okay, should I proceed further? You have noted down
Yes, sir.
everything? Noted?
2 minutes of copying, sir. Copying.
Okay, okay, go ahead. Writing and doing the work yourself will count a lot. There are not going to be any shortcuts, students. This is the way we have to learn each and everything in a step-by-step manner.
Copied, sir.
Okay. Now that we are coming to the most important part of the aromatic ethers. Aromatic ether. You know, this is a very important reaction. When I discuss, student, aromatic ethers. In aromatic ethers, what you have? You have OR group, which is attached to benzene ring. Yes or no? Tell me. Yes or no?
Yes, sir.
Okay. There are electron pairs, lone pairs on the oxygen, student. This is my R group. The R could be any group. CH3, CH2, iso, butyl. You can attach any group, no problem. But what type of group is this, students? And what type of reactions are going to be the main reaction? Now, this benzene ring is always a source of electrons. Yes or no? There are pi electrons. See?
Yes, sir.
This, you already know the structure of benzene when we discuss. These pi electrons are delocalized and they are present on the ring. Where electrons are present, student, which reagent will attack? Which reagent will attack? Attack if electrons are there. Electrophiles? Electrophiles. And electrophiles are those which have positive charge, students. They will attack where? Where there is a more electron density. Where there is a more electron density. Yes or no? Tell me. Where is more electron density? There the E plus will attack. Now, what type of group is this? You see OR group. If you know, the OR group is electron releasing group. Oxygen. Whenever I said there is a lone pair of electron on the atom attached to the benzene ring has the ability to take those electrons. Benzene ring is an electron sink. It will take the electrons if they are present on the atom on the top of it. If there is a lone pair of electrons, what happens then? What happens then, student? You are aware of this. The OR group has got a lone pair of electrons. Okay? You are so well used to this. It has to be. So this lone pair of electrons, but this benzene ring can withdraw. How? This is how it happens. So this is a pi electron. The pi electron will shift, student. The result will be what? OR, OR, and this will become a double bond. One lone pair of electron gone, and this pi bond will become a lone pair of electron, student. Okay? And this will become positively charged.
Okay, sir.
Now, this where the electron density has increased. Which position is this? Which position is this, student? What position is this? What position is this called in the benzene? Tell me, what is this position, students? If there is any group next to this, what is that? 1, 2, 1, 2 position is known as what? Ortho?
Okay, sir. Ortho, yes, sir. Madam.
1, 2. And now further, because there is a conjugation, further it will continue. And the result of this is, students, what happens, students? As you can see, this becomes double. This becomes negative. And now, similarly, there will be one more. We have shown this here. See how many possible structures are there. They have been shown here. So this is a para position 1, 4. What is the result, student? What we are finding? We are finding the negative charge is now increasing at ortho and para positions. Yes or no? The negative charge, students, this is increasing at what positions? Ortho and para positions. So the electrophile is going to come. So where it will attach itself? Tell me. Ortho, meta or para? Where the electrophile is going to attach? To form a bond with carbon and hydrogen. It will replace the hydrogen. It will come at ortho and para positions.
Yes, ortho and para.
Ortho and para positions. And it will not come at meta because there is no negative charge on the meta, student. So we are going to get ortho and para groups. Therefore, we can say that OR group. Question: what type of OR group is this? Question: what type of group is OR, students? Is it activator or a deactivator? Is it increasing the rate of the reaction or decreasing the rate of reaction? And at which point the electrophiles are going to attach? That is
so they'll attach at ortho and para, and I think this will activate.
This is activating the benzene. It activates. Yes. So it will make the reactions faster, students, and even weak electrophiles will be ready to come and attach and do the substitution reaction. Electrophilic aromatic substitution. This is called electrophilic aromatic substitution, students. OR group will activates the benzene ring, and it is ortho-para directing. Important point to be noted, students. This is ortho-para directing, and this will activate the benzene ring. Towards what reaction? Towards what reaction? Electrophilic. These reactions are what type of reaction, student? I am talking of electrophilic, as I have written here. Substitution, I may say aromatic substitution because the substitution is taking place at the benzene ring, students. And we have already shown what we were trying to show here. This is the representation, resonance stabilization. OR group is plus R group, student. It is releasing electron by resonance. Resonance means the conjugation has taken place, students. Conjugated double bond, single bond are present. The result is ortho-para directing, and the reaction rate will speed up, and even weaker electrophiles may attack. So now we will be discussing some of the examples of this electrophilic aromatic substitution reaction, student. Let us see examples. The first I have been written here, halogenation, students. What is a halogenation? So phenyl alkyl ethers undergo usual halogenation, and you can do, for example, first one I am talking of halogenation, students. Halogenation reaction. So if I take this compound, student, if I take this compound, then what will happen? Can you tell me what is the name of this compound, student? What is the name of this compound? Tell me what is the name of this compound?
So ethanoic acid. Wait, that's the
not an acid.
Yes.
It's ether. What did I say about acid? I have told so many times, methoxybenzene, this is called anisole, students. Very important, very important. Just like phenol, instead of H, you have CH3. Tell me what will be the products and which will be the major product. Question was asked in the paper. Write the products and tell the which is the major product in this case, student. Write the products and which is the major product, student. Important question. What is your answer? You have 30 seconds with me. You already have been told ortho-para directing groups. OCS3 is ortho-para directing. So what will be the product, student, then? What is the problem? How many products you are getting? You will get mixture of two products. One will be at ortho position and other will be at para position. Now, which is the major product in such cases? You have been told so many times, students. Ortho bromo anisole, para bromo anisole. Now, which is the major product? This one or this one? Tell me which is the major product. Always we are saying this is a major product. Any doubt here?
Yes, sir.
These big groups and these charges are want to be farther away from each other. So this is more stable than this. This is the major product. These groups are very close to each other. So there will be repulsion as well as there are negative charges, electron pairs. Electron pairs will repel and they will try to go as farther apart as possible. So halogenation in this student, in halogenation, which is the electrophile which is used? Tell me, they have asked this question. Which electrophile is responsible for this reaction? Which electrophile is responsible for this reaction, student? Because you are adding Br, Br. When it comes near this, what happens? You already know how the story changes. So you get Br plus. This is Br plus is the Br with a positive charge, student. That is the attacking reagent, which is an electrophile, which is an electrophile. So I'm saying Br plus. This is an electrophile, which will positive ion and then it attacks. And when it approaches the benzene, this is how it happens. This attacks this like this. So this becomes polarized and Br minus leaves. Br minus will leave, students, and then one hydrogen will come from here, HBr, Br and HBr. So it's a substitution reaction because hydrogen of the benzene is replaced by Br. So there is a hydrogen here, hydrogen attached to the benzene. Any doubt? Tell me. Written?
2 minutes, sir. 2 minutes. Copy.
Okay.
Yes, sir. Copied.
Okay. Coming to the okay, this is let me go first. Some more reactions. I'm not done. I need a blank page. Okay, students. Then what we are talking, students? We are coming to another important reaction. Friedel Crafts alkylation. You are aware of this? You are aware of Friedel Crafts reaction, students?
Yes, sir.
What are the reagents which you use in Friedel Crafts? Alkylation, what reagent you will use? You already know about that. We have uploaded in YouTube also. Friedel Crafts reaction is very important. You have an alkyl halide, and which is the Lewis acid which is used with this. What we use? Anhydrous. Again and again we use that AlCl3. And you can use some non-polar solvent. Non-polar solvent. You can see that. Because the water will attack the aluminium. It's a Lewis acid. Lewis acid. So what happens, student, when I have such a situation? What is we are saying, student? You have this group and you are adding, supposing CH3Cl anhydrous AlCl3 carbon. What will be the products then? What will be the products? Write down the products. To write down the product, students.
Yes, sir.
What are the products? Can you name the products? One you will get CH3 group here, and other you are getting CH3 group attached at the para positions. So what is this? 2-methoxytoluene, which is a major product, minor and major product. 1, 2, 1, 2, 3, 4. So 2-methoxy, and this is our 4-methoxytoluene. You know what is toluene? CH3 attached to benzene. Now in this case, what is the electrophile, student? Which is the electrophile in this case? Question is there. Which electrophile is attacking this? Can you tell me, student, which electrophile is there in the Friedel-Crafts alkylation? What happened? CH3Cl, AlCl3. What is AlCl3? This is a Lewis acid. This is a Lewis acid. It is in need of the electron, and you know where are the electrons. So what will happen? This can go and you can get CH3 plus this electron, it can go and it can get attached to this. So minus, got it? So this is the electrophile here, which attacks the benzene ring, and it will substitute one hydrogen from here. You are aware of the mechanism which we have discussed earlier also. Interested students can see our YouTube lecture on Friedel-Crafts reaction. Okay? This question, they have given this question many times, student. Don't underestimate this question. It has been asked so many times. So they will say CH3, CH2, Cl, and anhydrous AlCl3. You have to write the product, students. You have to write the products. What products are there? You already know. Which this will be CH2, CH3 group, which will get attached at ortho and para position, students. So no problem here. You already know about this. CH2, CH3 plus O, CH3, CH2, CH3. Yes or no?
Yes, sir.
Major and minor products. We should be very clear, student, when we are doing this type of reaction. They are important for the exam. If you are finished, I will proceed further. There is another one which I am saying, Friedel-Crafts acylation, student. What do you use in acylation? RC double bond OCl. Alkyl, instead of alkyl, you have a acyl group. So if we give you this question in the paper, this is my anisole students. I react this with the CH3COCl, and you are given anhydrous AlCl3. Then what is the product? You have to write down the product, student. You have
Yes,
1
sir.
minute to answer the question. So every time you are getting 1 minute for every question, students.
Yes, sir.
What is the name of the products? OCH3, and what is the, you know, CH3 C double bond O. This is the electrophile here, carbon. So what will happen? COCH3 plus OCH3. So what you have? COCH3. You're getting these two products. What are the names? You know what is the name of this compound? What is this compound called? We have told you so many times. Acetophenone.
Yes, sir.
So this is what? If I, this is 1, this is 2. 2-methoxy. Acetophenone. And what will be this? 1, 2, 3, 4. 4-methoxyacetophenone. 4-methoxyacetophenone. So these are all examples where electrophiles are attacking. Electrophilic substitution reaction. Electrophile student, they sometimes ask what are the electrophiles in this reaction. You should note down very clearly, students. Note down very clearly.
Yes, sir.
Okay, good. So far, so good. Okay. So further we are coming to nitration. I'm talking of nitration. I said anisole reactions are very important. Anisole. You should know the formula of anisole. Just as phenol, it is anisole. It is an aromatic ether, which we are discussing. What happens when we react with concentrated nitric acid and sulfuric acid mixture? You have anisole. What you are doing? Concentrated H2SO4 plus HNO3. What will be the products, students? What is the electrophile here? You know what the mixture gives? NO2 plus ion.
Okay, sir.
Nitronium ion. That is an electrophile. And what products will be obtained, students? Oh, this is my aromatic ether. The NO2 group will come at ortho, or NO2 group will come at para position, students. So you are getting two products. 2 nitroanisole and 4 nitroanisole. 1, 2, 3, 4. 4 nitroanisole, students. This will be the major products. This will be the minor products. These are all examples of what we said. What
Yes.
type of examples are these? Electrophilic aromatic substitution reaction. They are examples of electrophilic aromatic substitution reactions.
Yes, sir.
Okay. This is actually the end of this reactions of the ethers, and few of the questions which are important, which they are asking again and again to the students. Question. You are given student OC2H5. So this is ethoxybenzene. So here they ask you a question, write the products. Question 2. They asked this question in the paper, students. OC2H5 concentrated HNO3 H2SO4.
Yes, sir.
What is the first case?
I don't know. I think I'm making a mistake.
Why? We already told you this carbon oxygen linkage which will be broken. See what we have. You have something like this. OCH2CH3. So either you break here or here. This is not going to break. We told you so many times. This is not breaking, so it breaks always this side. So what will happen then? The BRB is going to get here. Alkyl halide. Because this is plus, this is minus. And O minus. If I say this is O minus, O minus, O minus will take H plus. Very clear. This is plus, this is minus. If then this is minus. This is minus, this is plus, this electron pair goes with the oxygen, then what oxygen will take? Plus, positive. So why should I do any mistake in the paper? I should know how the reaction is.
Yes, sir.
Play students. So you will get this. And our second case. This is a simple nitration. What is the problem? We have written already. Nitration, they gave the question in this form. That's all. So if you write like this, then what you are having? Two nitro group. Nitration, example of the nitration, students. And you have to write major and minor.
Yes, sir.
No problem in these cases, students.
No, sir.
Okay. Now let me see, some more questions are coming. More questions are coming, student. The questions are like this, students. In the case of the ether, for example, he says, write the names of reagents and equation for the preparation of following ethers by Williamson synthesis. Important question. I'm saying important question will be discussed. The most important method for the preparation of ether was which one? Williamson? Yes or no?
Yes, sir.
And what we do in this alkyl halide and sodium alkoxide, what do you get? ROR dash. And what was the catch? What was the main thing? The Rx should be 1 degree. Otherwise, what will happen? Then this reaction doesn't take place because it's an example of SN2 reaction. We already know about all those things now. Elimination will take place otherwise. So first question you have to prepare 1-propoxypropane. 1-propoxypropane, student.
Yes, sir.
1-propoxypropane, what is the formula? 1, 2, 3. O CH2, CH2, CH3, and prop oxy. That means you are preparing this. So if you want to prepare this, then what is here? There is no problem because alkyl halide you can use CH3, CH2, CH2, Br, and then you can use CH3, CH2, CH2O minus, and Na plus. So what will you get? This one. This is 1 degree, no problem here. If you are coming to question number 2, students, how will you prepare ethoxybenzene? Always write what you have to prepare. You have to prepare ethoxybenzene, student. So you have to choose by Williamson method. What should be the reacting reagents?
Yes, sir.
One you have alkyl halide and other. What you have used? Tell me. Which alkyl halide has been used? Which alkyl halide has been used, students? Which alkyl halide you are using? One alkyl halide and one sodium alkoxide. One group is this, other group is this. So which one we will select?
Yes, sir.
Tell me which one you have selected. Name the reagent. Name the alkyl halide which you have used. This must come from Rx. We know already. Because this is not going to break. This bond is not possible. So what do you have? CH3, CH2, Br plus. Then what is the other one? Na plus. Sodium alkoxide, students.
Yes, sir.
Okay. Next question. What is that? Write the names and reagents and equation for the preparation of the following ethers by Williamson synthesis. You have to write. First, you should be able to write the formula of this. What ether is this? What ether is there? 2-methoxy, 2-methyl propane. So how will we write 2-methoxy, 2-propyl ethene, students?
Yes, sir.
One question out. What was the name of that compound? Two, which we wanted to prepare
Sir,
student.
I think I'm having internet net issues. I can't hear your voice properly.
Some net problem.
I think so, sir.
Okay, then you can take this as a homework because we are finished this chapter. Next time we will start with aldehydes and ketones. Then, okay, we will start with aldehydes and ketones next time. Okay. Network coming or not?
Hello?
Hello, you are getting network problem?
Yes, sir. I think I disconnected right now.
Okay, then we will meet you in the next class. This
Okay,
chapter
sir.
is finished. We will start with aldehydes and ketones.
Okay, sir. Okay. Thank
Okay,
you, sir.
then good night.
Good night.